Salutations from space and aloha from Earth, friends. This is Gemini Brett of More Than Astrology. We have just experienced or are experiencing a total lunar eclipse, a supermoon lunar eclipse on January 20th, 2019 in the first degree of tropical Leo. In fact, the eclipse began as Moon was in the last degree of Cancer and she ingressed Leo during the eclipse, which perfected the middle of the total lunar eclipse. Moon was 51 minutes out of 60 minutes in a degree, right? So in the first degree of tropical Leo. And this video in many ways is made as a response to a question that was asked by the wonderful astrologer Tammy Brunk at the Shamanic Astrology Mystery School's Facebook page, where basically the discussion was around the eclipse events as accelerations of time. And this is something I first learned from Kaylin Castell and Daniel Gemario at the Shamanic Astrology Mystery School. And the general idea is because during a lunar eclipse, we experience all of the lunar phases that we experience during the course of a month, but compressed only into a matter of hours. In this case, it was about 3 hours, I think maybe 4 for the eclipse from full through partial, the total eclipse, which is kind of like the new moon, right? She's blood red because we can only experience these great portals, of windows of gnosis, of the soul, if we have the courage to embody in a vessel with blood running through its veins, I like to say. Or you can get into the whole idea of the refraction of red light versus blue and sunrises and sunsets of Earth being projected onto moon's surface and whatnot, but that's just not as interesting, you know? Anyway, so the blood moon, the total eclipse bit, that's like new moon, right? New moon's like a no moon. We don't see the moon because it's blinded in the glare of the sunlight when moon is between Earth and sun, unless it's so directly between Earth and sun that we see an eclipse if we're in the path to do so. New moon typically is moon in her dark phase, right? 3 days of darkness, always prophesies. Well, it happens every month for moon, right? That last little crescent bow goes into the darkness, new moon, and about another day before she appears with the waxing crescent in the west. All right. So the idea of a lunar eclipse in this sense as an acceleration of time is because we experience all of the phases that we do during the course of a month, but in a matter of hours. Now, some of the phases we see aren't exactly like the month's lunar phases, right? Like we never get a perfect square moon during an eclipse because the Earth is round and so is her shadow. So we'll always have some curve. And then you get to this point where the moon's curve is unlike anything we see in the reflection of sunlight on moon's surface during the course of a month, because as we know, she waxes from new through the crescents to half. And then the gibbous moons are half plus a bubble, right? So she's egg-shaped, and it's, would that be convex or concave? I'm losing the definitions, but the phases that we see like this one during the course of a lunar eclipse are the curve is going in the opposite direction than we typically see in the half moon plus a bit of a bubble, a gibbous phase. I hope that makes sense. Anyway, in my explorations of lunar eclipses, just in the past few days, I taught a class for the National Council of Geocosmic Research in San Francisco this weekend on eclipses and eclipse cycles. And a lot of this actually came through studying this animation. This is from timeanddate.com, and this was this January 20th, 2019 total lunar eclipse in the first degree of Leo, and just like through the phases. So the moon, who is rising in the east and setting in the west, but at the same time, very slowly moving from the west to the east. That's the secondary motion or orbital motion through the Earth's shadow, the umbra, and the eclipse begins, right? And then we come and we get to this like last sliver before now totality, right? And this is like the new moon phase. And then we're in the blood moon bit for a while. Depends on the eclipse, how long that lasts. And there's a lot of very interesting factors, some that we will look at as we move through the slides that I have prepared for you. And moon moves through the shadow, and now after she's coming out of the shadow, we see the crescent and waxing towards half and kind of 3/4, and then full moon once again when she's fully out of Earth's shadow, right? But what tripped me out when I was watching this video was this. We're just going to watch the second half, and I'm going to pause this too. This is the second half, right? So after the total eclipse, and now moon's passing out of her shadow, and here, so we get the return of a crescent bow on the moon's surface. Well, so what really intrigued me is this. That shape there is the shape from the northern hemisphere, and this is a northern hemisphere animation. It would be different down south, backwards. This is the shape in the northern hemisphere of the waning crescent, the last phase of the lunation cycle before moon goes into the darkness. But here we are seeing that waning crescent shape after moon is in the darkness. So instead of going from waning crescent to new in this acceleration of time through the image of the phases, we're going from new to waning crescent, right? In other words, we're going through time backwards. And so I'm going to rewind this, and we'll watch as this eclipse begins. This kind of same idea. We're going from full, right? And as moon enters Earth's shadow, moving from west to east, Rahu starts taking bites out of the moon. Oops, trats. Let me see if I can speed this up and pause it where I want to pause it. Right. And again, this is not a moon phase we could see, but if you just flip that curve around, this would be like a gibbous moon, yeah? But with the lit side on the right or the west, this is like the waxing gibbous moon that happens during the first half of the moon cycle. So again, here we're going from full, and we're going backwards through time, through the waxing gibbous and the waxing half and the waxing crescent. This looks a little strange in this particular animation because they just have it focused on a not moving moon. Otherwise, like we would literally see like kind of a curved path. Anyway, I watched it. I don't want to explain that too much more. Maybe you can take my word for it, or just at least in this half, you can see for sure that we go from new moon, and as the crescent returns, we're moving from new to waning crescent to waning half to waning third quarter, because we're going backwards through time. And in some senses, this I think really makes sense for a lunar eclipse, because typically we work in the synodic cycle of the phases, right? We say like new moon is the time for planting intentions. And I like to say that's the seed that will sprout at the waxing half, the first quarter moon, and flower at the full moon, where we have a whole night, full moon rising at sunset. We have a whole night to play with that moonlight and reflect upon the seeds that were planted, and they tend to sprout with some tension. This is some of the idea of the half moons, or the first quarter moon, the waxing half moon, that sprouting ain't easy. We got to bust through the soil and all that. Anyway, so the full moon is, in a sense, a response to the new moon. When we think of the harvest and the seed at the new moon time, planted in the darkness, right, in the dark soil, and it sprouts through, we can start to see what it's about, and then it flowers, and now we know that plant. And if the flower is willing to be pollinated, and that takes some courage, then fruit will grow from it. And the fruit, which is this third quarter or waning half moon, carries the seeds that will be planted in the soil of the next. Okay. So let me get back to this question that Tammy asked, because I want to explore this, and it actually is taking this contemplation further of moon. Yes, she accelerates time during the eclipse. We see all of these phases, and some of the phases are themselves kind of backwards, right? Because instead of the curve doing this, it does, this. It's kind of hard to show with a mouse, right? And then also we're moving through the phases, like from new to the waning crescent instead of from new to the waxing crescent, for example. But it goes through the whole cycle backwards. And as a full moon typically is a response, in a sense, to the intention or seed planted at new moon, this makes sense. But how far backwards would we go? All right. So first of all, we're going to have to talk about a few different months. All right. So there's many different ways to see the month. One is the animalistic. And you'll see I'm showing Lilith drawn here. And one is the draconic. And I show the North Node drawn here. One is the synodic. I show the sun and sidereal, the earth. We get back to those latter. But this is the idea of the animalistic month, all right, which is about 27.55 days. Moon and Earth are not in a circular experience. Moon does not orbit Earth at the center, rather than this kind of binary dance. Moon is actually very large compared to the Earth, 3/11ths of the Earth's size by diameter, and their orbit is elliptical participation. And all elliptical orbits have not a center. Circle does that. Ellipses have two foci of kind of energetic agreement. So one of the foci of the Moon-Earth dance is within Earth's bounds, pretty close to her edge. The other one is a dark point in space that astrologers have come to call Black Moon Lilith, which is interesting in all sorts of mythic, etc. levels. But for now, we'll talk astronomically. Lilith is this kind of dark point in space, or black point in space, that is one of the two wells of the Moon-Earth gravitational agreement. And the other one, again, is within Earth, okay? Now, if on Earth we look through Lilith, we look to the point of Moon's path called her apogee, which means the furthest from the Earth. Now, opposite the apogee, or on Earth, opposite in the zodiac from Black Moon Lilith, we find Moon's perigee, and that's the point of Moon's elliptical orbit where Moon is closest to the Earth. Now, closest means biggest, brightest, fastest. And these days we call those supermoons. And furthest, apogee, means coldest, you know? Well, not necessarily coldest, because that probably has more to do with the sun than the Earth. But anyway, furthest, slowest, smallest, dimmest. Okay, it's an interesting thing, and it varies by, I think, about 10%. Well, depends on what you're measuring from. We'll say the supermoon appears to be 30%, the perigee moon appears to be 30% larger than the apogee moon, or what some call the micromoon, supermoon and micromoon. Anyway, so that's one of the months in consideration. Another month, and this is Moon from node to node. Moon is not on the same path as the sun from Earth's point of view, or else we would have an eclipse every new moon, a solar eclipse, and a lunar eclipse every full moon. Typically, a new moon will have moon above or below the sun. It's actually kind of featured in this image here, created with the help of the amazing Anna Zaharia. We create a lot of these images together for Arts of the Chart. And this is an image of a new moon, but from the Northern Hemisphere's point of view, moon is above the sun. Or from the Southern Hemisphere's point of view, moon is below the sun. Either way, it's in what's called northern latitude. Every month, the moon snakes above and below the sun's path. And this is why there's so much dragon and serpent symbolism with the two, including that this mark here, the South Lunar Node, is the back of the King Cobra's hood. And if you put the North Lunar Node and the South Lunar Node together, you will see the snaking of a serpent, okay? And we call them Rahu, the head of the dragon, and Ketu, the tail of the dragon. And the dragon, the node points are where the moon's path, the path of soul, I like to say, crosses the sun's path, the path of spirit, right? So every month the moon is snaking above. And if we look at the time from a node to back to a node, then that's the draconic month of about 27.21 days. We'll see that in a second. Here's an image of the eclipse limits, okay? How close moon and sun need to be to either north or south node for a solar eclipse at new moon or a lunar eclipse at full moon. And the ranges are different for solar and lunar eclipses. Here they are. All right, well, this eclipse that we recently had, I mean, hopefully you can see why the moon and the sun need to be near the nodes for an eclipse to happen. Hopefully this illustration helps if you don't know this already, right? Like here, moon is above sun, no eclipse for you. But if the two met over here, then the moon would be right in front of the sun from Earth's point of view. In other words, solar eclipse. And if sun was here and moon was over here, opposite Earth from the sun, that's full moon, right? And if they do that close enough to the nodes, then the moon is in the Earth shadow, lunar eclipse, right? So every year, as the sun finds either his way to the south node or to the north node, and they're about 6 months separated, we're in eclipse season. When the sun is near a node, that means the new moons will be near enough the nodes for a solar eclipse maybe, and the full moons will be near enough the nodes for a lunar eclipse maybe. All right. And these are the limits. And this recent eclipse found moon 4 degrees and 5 minutes from the north lunar node, Rahu. Okay. And that's within this range. That could either be a partial lunar eclipse or a total lunar eclipse. So why was it total? And the answer is this. Lilith. Moon was near opposite Lilith. Well, remember that Lilith, looking through Lilith, is moon's apogee, the furthest point of moon from Earth, the micromoon, the small moon. And opposite Lilith is moon's perigee, closest to Earth, big moon, right? Well, big moon means not that there is more moon to eclipse. It might seem that way, but the size of the moon is not actually changing. It's just closer to Earth and therefore like closer to the big part of Earth's shadow, which like any shadow goes from like the size of the thing into a little pinpoint and then it disappears, right? So the closer the moon is to the Earth, the more likely you are to have a lunar eclipse. The longer the lunar eclipse will be too, if it's close enough to the nodes for an eclipse to be going down, as this one certainly was. In the first degree of tropical Leo, here a cast for San Francisco, California. And we're going to look at it from a different point. So again, because moon was near opposite Lilith, moon is at perigee, which is the supermoon. Moon is bigger, it's closer to Earth, it's deeper in Earth's shadow. And so this eclipse that was within the bounds of maybe partial or maybe total was total because she's a supermoon at the time. All right. So the draconic month, yeah, we see 27.21 days, moon north node and back to the north node again, or south node and back to the south node again. Animalistic 27.55 days, moon furthest from the Earth, back to furthest from the Earth, apogee to apogee, or closest to the Earth, back to closest to the Earth, perigee to perigee, on average 27.21 days. But this question of how long does it take for moon to appear in each of her phases, the same degree of a zodiac, this is a question about these two other moons. One, the synodic moon. Synod means meeting. And we're talking about the meeting of the moon and the sun, right? So synod is new moon to new moon. In other words, the phases of the moon are the synodic, 29.53 days on average, okay? Sidereal means of the stars. And this is then moon moving through the nakshatras, the lunar mansions or houses in the sky. Or we could also see this, and I'm symbolizing it as you can see here with the earth glyph of moon moving across the medicine wheel, the cardinal directions, which from the center of Earth are the tropical zodiac, right? And the 0 Aries, 0 Cancer, 0 Libra, 0 tropical, they mark the cardinal directions, east, north, west, south, respectively, in the order that I just spoke them. So basically moon moving through the signs of the zodiac, sidereal, 27.32 days on average. All right. So when moon from 1 degree Leo, where she was just full moon, she will return back to that same degree in about 27.32 days. But she won't be full that time when she returns there, about 27 days from this full moon, this super moon, total lunar eclipse, which was January 20th, 2019. Well, 27 days after January 20th is what, February 17th? So moon will be back to the 1st degree of Leo around February 17th, but she won't be full because the sun in that 27 days, we'll have moved about 27 degrees and we'll be at around 28 degrees Aquarius with the moon at the 1st degree of Leo. See? All right. So it takes another couple days for moon to catch up to oppose the sun. And that's just the difference between the synodic and the sidereal. And let's look at what that is exactly. Get a calculator out here and we'll say 29.53 days, the months, the synodic months of moon phases, minus 27.32 days, moon through the signs of the zodiac, and we get 2.21 days. Okay. So the question is now, what is the moon's phase 2.21 days before full moon? And the answer is the waxing gibbous moon. But like exactly what? So I can take these days here, all right, and multiply them by the degrees that the moon travels per day on average. The moon moves about 13 1/3 degrees per day on average. And we get about 29.5 days. Or sorry, no, we get about 29.5 degrees. And fascinatingly, that's so close to the synodic cycle, you find a lot of mathematical wildness when you play with moon stuff. Anyway, let's call that 30 degrees, right? And that's going to take us into this idea of, yeah, we usually teach moon phase through these 8. New, waxing crescent, waxing half, waxing gibbous, full, waning gibbous, waning half, waning crescent, right? But if we're talking about 30-degree differences, well, then we can map the phases of the moon, as I really like to the whole sign aspects that we use astrologically. And we would go from new, and I should say this whole thing is based upon where the moon is in the houses at sunset. So we bring the sun in, all right? So the sun's at the descendant, and the new moon is with the sun, and therefore the new moon is at the descendant at sunset. Make sense? Well, if the moon waxes, at sunset, we see Diana's bow appear. And really, this would kind of be, you know, the bow would be pointing to the sun. Bow would be pointing to the sun. We're just showing them on the right here. Again, an image that Anna helped me create. And you can see at the bottom, lunar phase correspondence with whole sign aspect and equal house location at sunset. It's a mouthful, but the whole sign aspects would be semi-sextile, sextile, square, trine, quincunx, opposition, right? And then on the waning side, quincunx, trine, square, sextile, semi-sextile. All right. And these work like physically. The waxing half moon, for example, is 90 degrees from the sun. And if you're in the place where that is happening in the moment that the sun sets, then the moon will be at the highest point of the ecliptic or the sun's path, right? Now that it's not the midheaven. The midheaven would show up on a quadrant house wheel. I know this is like advanced language for some of you, but not for some of you. But like a Placidus or Porphyry house wheel or whatever. The midheaven is it's cardinal. So in the northern hemisphere, the midheaven is typically south. Southern hemisphere, north. Between the tropics, it can go either way. It's a tale for another time. But the equal sign 10th house cusp and the equal sign 4th house cusp, while they're not angular like that, where they're not aligned to the cardinal directions like that, I should say. They're not directional. They are where the top of the peak, the 10th house cusp of the equal sign wheel is at the top of the peak of the ecliptic. It's closest to the zenith, top of the sky. So some call that the zenith. And then down here at the 4th house cusp of an equal sign system, the nadir. So while, for example, in the northern hemisphere above the Tropic of Cancer, where the midheaven is always due south, the waxing half moon is not necessarily going to be due south at sunset because the sun only sets due west 2 days a year. What it's going to be is perfectly square to whatever the ascendant descendant axis or azimuth is. And I know that's pretty advanced language, but anyway, to kind of bring it back to the matter at hand, I think it's a beautiful thing to contemplate the moon's phases in 12s. And they align, therefore, not only to the whole sign aspects that we use in astrology, the so-called Ptolemaic or major astrological aspects, plus the 30 and 150 degrees, the so-called inconjuncts of this mystic rectangle, the semi-sextiles and the quincunx angles, 30 and 150. And I just like to keep that like aligned to the sacred 12, though I also honor the eightfold system. All right. So let's play with this, and with especially this idea of 30 degrees difference in phase every time moon returns to the same degree of the zodiac. And the way we will do that is by starting with this supermoon total lunar eclipse we just have. And I'm cast this chart for a haiku in Maui, Hawaii, because at the time that first degree of Leo was in the 12th house, and I can make that in the whole sign. I can just bring it down right onto the horizon, and it'll just kind of be easier for us to track this, I think. And so what I'm going to do is I'm going to add a transit wheel to that. And I'm just going to show you the next time the moon is at 1 degree Leo. So first of all, what phase is she in here? Well, it's the lunar eclipse. That's a full moon. That's opposition, right? By aspect, or full moon by phase. And there's a window right here above where it says tropical zodiac on the right, where if I hover over the moon, you will see 179 degrees and 60 minutes. Well, that's interesting. There's 60 minutes in a degree, so that's 180 degrees. In other words, the opposition. In other words, the full moon. Okay. So when moon gets back to 1 degree Leo next month, and we said how this is going to be 27 days later, February 17th from January 20th. Now look at the moons at 152 degrees and 16 minutes. Okay, so we've subtracted about 30 degrees. We've actually subtracted about 27.7 degrees. And let me just say here, when we're doing those calculations and talking about this, we're speaking about averages. I said the moon moves on average 13.3 degrees per day. On average. Sometimes she's moving more than 16 and sometimes about 11, right? And it depends on how close or far she is from the Earth. Now, Earth's orbit about sun is not a circle either. So when we say that the sun moves on average 1 degree through the zodiac, we're actually speaking about, first of all, Earth's motion or orbit of the sun, but our experience is sun moving through the zodiac when we are on Earth, as we are. But Earth is not always moving at the same speed. Earth's perihelion, or Earth when it's closest to the sun, is in early January, January 2nd this year. And she's furthest from the sun in July. So when she's closest to the sun, Earth's moving fastest in January, and therefore sun is moving faster than 1 degree per day through our zodiac. And in July, the sun appears to move slowest through our zodiac. So we're playing with averages here. But very importantly, just stick with this feel that when moon gets to the same degree of the zodiac each month, she's going to be about 30 degrees less in aspect or phase than she was the month before. So we assume from 180 to about 150. And that's February 17th. We'll add 27 days and get to what? About March 14th. Sorry, it's February 17th. March 16th, right? So averages. And February has that weird short month situation, right? So my math was bad there too. Anyway, moon phase here, 125 degrees. And so you can see we're not subtracting 30. Again, game of averages. Maybe the last time I'll say that. The next time moon returns to the first degree of Leo about 27 days later. Now we're at 97, 98 degrees, right? So if we were subtracting 30, 30, 30, now we would be at 90. But you'll see she stays pretty close to that, especially as the averages start to work out over the course of the year. Here's May, and now we're at 71 degrees. And here's June 6th, and we're at 45 degrees. And here is July 3rd. Moon is 19 degrees from the sun. And on July 31st, moon is now 7 degrees from the sun in the other direction, right? So we went from opposition to very close to the new moon, right? As moon moves 13 degrees on average, and this is 5 a.m. This will definitely be the day of the new moon in Leo this year, 2019, July 31st, Pacific time. But it's going to be at about 8 degrees Leo, right? So I just want to go from January 20th, when moon was full at this degree of the zodiac, to July 31st, when moon will be near new at this degree of the zodiac, and we can play with that. At timeanddate.com, there's date calculators. Oh, and I already did this. Okay, so from January 20th, 2019 to July 31st, 2019, 192 days. All right, well, what is that? If I show you 192 times 2, we get 384. And folks who have done moon math magic know this number, because this one, watch, I'll divide that by 13, 29.53. Okay, that's 13 new moons to new moons is 284 days. If I subtract from 384, 29.5, we're going to get what we call the lunar month, or the silver year, the lunar year, 354. That's 12 new moons per year. All right. So I could speak about that for an hour, but I don't think you want to hear that anyway. Let me keep cruising on. We'll go into August, about 27 days after this. So August 27th, and we will find now this phase 33 degrees. We're going to add another 30. So we'll see that we're going to get to about 60 degrees next time. So moon to first degree Leo, September 24th. And now look, 60 degrees. And this is what I'm saying, like the averages are working out. All right, so over the course of the year, they'll play out for the most part. In October 24th, about the square, 87 degrees and 3 minutes, about 90, right? And what is that? That is the waning square moon, okay? So you just say that because I didn't earlier. I went from new a few months before. I'm going to do that. Okay, so here was the time of the about new moon, July 31st, right? And now the next one in August, this is the waning crescent. So remember, I started this by showing that animation of the lunar eclipse and saying that after the new phase, which is the total lunar eclipse, and moon's now passing through Earth's shadow and the crescent comes back, it's the waning crescent that first appears. We're moving through these phases backwards, month by month, as moon returns to the same degree of the zodiac. And we can do this for any degree of the zodiac, all right? So anytime there's a full moon, we could play this game. Look at about 27. So full moon is 180 degrees. Wherever that is in the zodiac, about 27 days later, the moon's going to be about 150 degrees from the sun, or the phase of the waxing gibbous moon, the waxing quincunx moon. Again, moving backwards, 180 to 150 to 120 to 90, 60, 30, 0. Negative 30 in a sense, which is the waning moon rising ahead, and then negative 60 here, okay? And we had already made it to this waning square moon, which helped me remember to share that bit. And now we'll get to the waning gibbous phases. Here's November, and moon's 114 degrees from sun, when at first degree Leo. And then here's December, and moon's going to be about 150 degrees. So you see 142. Again, game of averages. So this next one's going to be about 120 degrees, or the trine, when moon returns to the first degree of Leo, January 11th, 2020. And we actually, no, I meant to say, first of all, I meant to say 150. That, hold on. No, this is like back to 180. So we did 120, 150, 180. Sorry about that. This stuff's confusing already. It doesn't help to have a confused narrator trying to share it. So dig this. Right? We're near back to full moon status, right? So the full moon would have been the day before this. This is January 11th, 2020. I'll go back to the previous full moon, January 10th, 2020. Okay. Well, the full moon in 2019 was January 20th, right? First degree of Leo. And here, about 10 days and 10 degrees before, January 10th, 2020, we have our full moon. And 10 degrees before, so now in the sign of Cancer, right? That 10 degrees or 10 days, really, it's the solar year of 365.242 and change, minus the lunar year of 354.6. All right, it's about an 11-day difference between 12 new moons, or in this case, we saw 12 full moons in a calendar year, right? So we get our full moon about 354 days before the calendar year of 365.24 days, and that's going to be January 10th next year. And again, this is game of averages, elliptical orbits, and whatnot. All right. So to answer Tammy's question, which became my question, so I think it's a wonderful question. It takes about a year for the moon to shine in every phase of, in this case, as I'm sharing her 12 phases, it takes about a year for her to shine in each of the 12 phases in the same degree of the zodiac, where she will next be near full on January 11th, 2020. But not exactly full, 10 degrees separated from full. We'll see from here that we're going to do this 30-degree game again and again and again, right? And so here's February 7th, 2020, and we're at 162 degrees, where the month before, on January 11th, with moon at first degree of Leo, January 11th, 2020, we're at 170 degrees, okay? So we get to the next one. 162 degrees. Something, but this unfortunately is only showing up to 180. So it's 170 to 180, that's 10 degrees to 162. It's another 18 degrees. It's 28 degree difference. One was a waning, one was waxing. This one waxing. So, well, now we could do that again, and I'm going to show it's going to be about 130. Right, 134, and do it again. And we're just going to go through this every year, but it's not exactly the same every year, 107. There's kind of this 10-degree slippage in a year's time. I want to show you 3 years. I'm going to show you from full moon on January 20th, 2019, the first degree of Leo. 3 years later, okay, 2022, in January, we'll see that moon gets to the first degree of Leo pretty close to the same time, January 17th versus January 20th. January 17th, 2022, January 20th, 2019, the time of the eclipse. This one certainly will not be an eclipse because the nodes will not be anywhere near the full moon at that time. But notice that this moon is dang near full on January 17th, 2022, when she returns to the first degree of Leo in January that year. The full moon was just very shortly before that same day, but in the last degrees of Cancer. So why did that happen in 3 years? Well, this. Again, solar year, 365.242 days and change. Lunar year, and that means 12 new moons to new moons, 354.6. Why we go like this? Where's that calculator? The synodic year, the months, new moon to new moon, synodic month, 29.53 days on average. That times 12. 354, 0.36, right? I was saying 0.36 minus 365.242. It's a solar year, and it's about 10.9 or 11 days difference, right? Well, that means we need 3 years to take those 11 makes 33 days, which is about 29.53, right? So here's the trip. If you're doing a calendar based on the lunation, like new moon to new moon. You do 12 months a year, but every third year you have to add an extra month to get you back in alignment with the seasons, because the lunar year of 354.36 days is about 11 days shy of the solar year, 365.242 and change days. And therefore, it's an 11-day difference per year. It's a 33-day difference per 3 years, and 33 days is about equal to the lunation cycle, the synodic month of 29.5 days. But it's not equal to that. Where things really get equal is this. Where's that calculator? We take 3, what do we do? All right, 19 years. 19 years times 365.242 days per year equals 6,939 and about a half day. Okay, we'll divide that by the lunation cycle, the synodic month, 29.53 days. 235, almost exactly. Okay, so if I'm asking you in math class or whatever, in general, what's 1/3 plus 1/4? What do you need to do? You need a common denominator, yeah? And you say, oh, 1/3 is 4/12, and 1/3 was 3/12, and 1/3 is 4/12. And therefore, 3/12 plus 4/12 is 7/12. 1/3 plus 1/4 is 7/12, right? All right, well, if I'm giving you these numbers, 365.242199 and 29.53059, and I'm telling you to find the common denominator of those two, well, it just happens to be that number that we just saw. Let's play that game again. We'll do it the other way now. We'll say, okay, the lunation, new moon to new moon, 29.53, I'm going to go full on, 059 days on average, times 235. 6939.68. Okay, so about 6939.5 days is this common multiple or common denominator for the synodic month of 29.5 days about, and the year at 365.242199 days. 19 years, almost exactly, right? Look at that, 0.0002378. I'm going to subtract 19. I'm going to multiply that times 365.242199 to show you the difference is only 0.087 of a day. I'll multiply that by 24 hours and show you that the difference is only about 2 hours, okay? So 235 lunations, average lunations, is about 2 hours different than 19 tropical years, average tropical years. All right. So importantly, as we just had January 20th, 2019, a lunar, a full moon, let me say a full moon, and we know it was a lunar eclipse, and we know it was a total lunar eclipse, and in Intrepid software, Lilith is this L. And if you've been following all this, we're going to summarize this and bring it home, okay? I will put this on YouTube so you can like review this and pause it if it's bringing up new things for you that you want to take more time with. All right. So we had the moon and the sun close enough to the nodes for it to be a partial, maybe total lunar eclipse. And it was total because it's a super moon, and we can tell because the moon's at the near the perigee, which is the point opposite true black moon Lilith here in Intrepid software shown with this L. Okay. Well, in 19 years, moon is going to be full on the same degree. All right, that's this, what's called the metonic cycle. We saw how 235 lunations, so 235 full moons from this time will be 19 years. And I earlier was saying, let me wrap with you a little bit more before we share that. I was earlier saying that for a lunation calendar, a lunar calendar, a solely lunar calendar, lunisolar calendar, many ways to say this. So we're looking at phases for our months, okay? And the way to do that, by the way, is you have a 30-day month followed by a 29.5-day month, because what? The phases are 29.5 days. But they're 29.53059 days on average, and so that doesn't perfectly work. But anyway, the lunar year of 254.36 days, that's 12 times 29.5 about, is about 11 days short of the solar year, 365 and about a quarter days, right? So every third year you have to add a month, but it's not enough. And what happens is over the course of 19 years, we have 235 lunations. And the way it works is this, and I love this. We have 12 years of 12 moons, 12 years of 12 new moon to new moons, right? So when people tell you there's 13 moons a year, like tell them to get into some moon math magics, because they're not anywhere close. But if you want to do this linking of the lunation cycle, new moon as months with the solar cycle, it's very tricky, and it requires 19 years for them to sync very closely. Anyway, we saw within 2 hours, okay, that sync happens. 12 years of 12 months plus 7 years of 13 months. So cool. For 235, right? So 12 times 12, you get 144, very magical number. And then 7 times 13, you get 91. I'm going to play with that up here a little. Anyway, you get 91, right? And that combines for 235 lunations. We call this the metonic cycle, 19 years for this moon phase and calendar date synchronization, or moon phase in the same degree, we could say, synchronization, named after this Greek astronomer Meton from back in the day. But we knew about this when we built Stonehenge and the Great Pyramid and Newark earthworks in the States, Chimney Rock, everywhere, right? The 19 is encoded in there. And look at your tarot. 19 is the number of the sun. All right, so let me show this to you, that 19 years from 2019, which is 2038, we will have, a full moon on January 20th, 1 degree and 12 minutes Leo, right? So close to 0 degrees and 52 minutes Leo. Well, what's the difference? 2 hours. Right? We saw that difference in 2 hours. Let's play that game. What is 2 hours is divide that by 24, and 2 hours is 0.08333% of a day, in which moon moves 13.33 degrees on average. And that means it's going to be off by about 1.1 degrees, which definitely didn't happen here. Again, because we're playing with averages. Now, that's 19 years. But this will be an eclipse. It'll be a penumbral eclipse, a very little, like minor lunar eclipse. It's going to look like a full moon. And the reason is because the nodes travel in 18.6 years, not 19 years. Or really, on average, 18.618 years for the nodal round, the draconic round, which really matters because 0.618 is one of the golden numbers, phi. So that's been a strange adventure. And let me just summarize in English. Yes, because we experience every phase of a month's worth of moon during the few hours of a total lunar eclipse, the total lunar eclipse is an acceleration factor. However, we experience those phases backwards. So perhaps, just as a full moon typically is a time to reflect upon and flower the seeds that we planted at the time of the new moon, perhaps the acceleration that is most open during lunar eclipses is more of a remembrance of backwards motion. Now, this was a north node, which is typically about the forward energetic eclipse, and there are south node eclipses, so typically we'll use those factors to kind of determine is this futuristic or about the past. But let me just say this about what I'm learning here from lunar eclipse experience and symbolism and nature, that it seems to suggest that we have a portal, a very rapid portal to do some like remembrance, soul, which for me is what moon is anyway, soul retrieval. Secondly, answering this question that Tammy Brunk brilliantly asked of how long does it take for moon to express in every one of her phases at the same degree of the zodiac. Well, if we're talking about the 12 phases, as I like to, then it's about a year. It's really about a lunar year of 354.36 days. But if we work as they did in Hawaii and do with 30 phases of the moon, then it will take 19 years, the Metonic cycle. And as we went through this year by year, and I could show you the same thing day by day, the phases are moving backwards through the phases of the month, from new to the waning crescent, to the waning half or third quarter phase, to the full, to the waxing half or first quarter phase. And so not only is moon giving us this opportunity for remembrance or soul return and retrieval and reconnection, and a portal of acceleration during a total lunar eclipse for a month in the eclipse cauldron, maybe for 6 months since the previous set of eclipses, for a year, this time that the moon expresses each of her 12 aspect styled phases at the same degree as the zodiac, for 19 years, the Metonic cycle. And if I want to look at that 2 hour about difference or 1 degree difference, then I could probably multiply that 19 years times 360. And this is the first time I've actually thought of that. And it would be very much about averages, but that would bring us about 6,840 years, which very interestingly is about 1/4 of the precessional cycle, or the great or Platonic year of about 26,000 years, which dictates such things as the astrological ages and the sun on the cross and the turning of the new way, celebrated by such amazing calendrical calisthenics as the Mayan long count calendar. But this has been a long enough count already. So this is Gemini Brett signing off. I will see you in space.